Welcome back, everyone, to another Dynamic Explainer. Today, we're diving into something you literally interact with every single day, but probably rarely think about. We are going to completely demystify the operating system. And by the end of our journey today, I promise you're going to look at this hardworking piece of software in a totally new light. To really get this, let's start with a metaphor: the invisible bridge. On one side, you have the fluid, abstract nature of human thought, what we want to do. On the completely opposite side, you have raw, cold, physical hardware execution. The operating system? Well, it's that incredibly complex, invisible bridge stretching right across the middle. It takes our abstract human desires and literally translates them into tiny electrical pulses that a physical machine can actually execute. So take a second to really think about this. Without that bridge, how on earth would you talk to a microchip? Computer hardware on its own is honestly completely unusable. It doesn't speak English, it has no idea what a point or a click is, it only understands ones and zeros. It absolutely requires a middleman to make sense of anything we want it to do. All right, so here's our roadmap for today. We'll start with 1, the essential middleman. Then 2, 5 core OS engines. Moving into 3, traditional interfaces, and 4, modern interfaces. Before wrapping it all up with 5, the evolution of translation. Let's get right into it. Section 1, the essential middleman. Think of modern computing in 3 distinct layers. Up at the very top, in the bright, abstract space, is you, the user. Down at the absolute bottom, bolted to the floor, is the hardware, your processors, your memory, your storage drives. And sandwiched precisely in the middle, frantically managing the flow of data back and forth, is the operating system. So if we want to be formal about it, what is it? An operating system is essentially special software, running constantly in the background, serving as the necessary translator between human intent and hardware execution. Make no mistake, without this constant background manager dealing with the chaos, a computer would be impossibly user-unfriendly. Seriously, you wouldn't even be able to save a basic text file. Section 2, 5 core OS engines. Now, the OS is basically a bustling central hub. It's not just running one simple linear program, it is simultaneously juggling multiple, highly complex tasks in real time just to keep the machine stable, alive, and actually responsive to your next command. Let's rapidly break down these 5 core engines. First, you've got hardware control, handling all your physical inputs, outputs, and storage. Second is application management, loading your apps, keeping them running, and dealing with those inevitable crashes and errors. Third, system security, locking down the integrity of the whole computer. Fourth, monitoring usage, silently keeping a log of system operations. And fifth, user communication, providing the actual interface that lets you talk to the machine. Section 3, traditional interfaces, CLI versus GUI. Because here's the reality check. All those deep, powerful functions we just talked about, totally useless if you and I can't access them. To break the surface, the operating system generates a user interface, and this has largely evolved through 4 distinct paradigms: CLI, GUI, dialogue, and gesture. Let's kick things off with the foundation, the command line interface, or CLI. Think of your classic Windows command prompt. The CLI requires you to type in extremely precise instructions to get things done. Because of this, it's an incredibly powerful tool for programmers, analysts, and system techs who need direct, unvarnished communication with the machine. But for everyday users, it is terribly slow, highly prone to spelling errors, and requires you to memorize an entire dictionary of commands, not exactly user-friendly. To fix that massive accessibility problem, we got the Graphical User Interface, or GUI. This completely shifted the paradigm to what we call the WIMP model: windows, icons, menus, and a pointing device, like your mouse. It was designed specifically for the average person. By relying on pictures and visual symbols instead of typed code, the GUI completely shields us from all that underlying complexity. But comparing the two reveals a really stark, undeniable trade-off. The CLI gives you direct communication and takes up barely any memory space, but it comes at the steep cost of high human error. The GUI, on the flip side, eliminates memorization entirely, but all that visual clarity, it demands massive hardware resources and a way more complex OS to operate. It is the classic tug-of-war between raw power and mainstream accessibility. Section 4, Modern Interfaces, Voice and Gesture. First up, in the modern era, we have dialogue-based interfaces. You know these perfectly well: Amazon Alexa, Apple Siri, or that voice-activated navigation in a new car. Here, the system utilizes the human voice itself to issue commands, giving us a completely hands-free experience. And this creates a fascinating real-time workflow that happens in 4 instantaneous steps. First, the human gives a voice command. Second, the operating system jumps in as an instant translator, converting your acoustic voice waves into a binary stream. Third, the machine logic processes that translated request. And fourth, it outputs a verbal audio response. The OS is doing some incredibly heavy lifting in real time here. Then, we step into gesture-based interfaces. Think about waving your foot under your car's rear bumper to pop the trunk, or twirling your finger in the air to crank up the volume. These rely heavily on computer vision and image processing, but they come with some pretty strict technical vulnerabilities. They usually max out at an operational range of about 1.5 meters, and if the OS isn't programmed absolutely perfectly, everyday unintentional physical movements can easily trigger false inputs. Looking at the modern sensory matrix, we can impartially compare their environmental trade-offs. Dialogue is amazing for accessibility, and it's completely hands-free, but it totally fails in high background noise and has a limited command vocabulary. Gesture, on the other hand, is the most natural interface possible with 0 mechanical inputs, but it is strictly boxed in by operational range and accidental body movements. They both really push the boundaries of how we interact, but they definitely introduce unique environmental hurdles. Section 5. The evolution of translation. Now, evaluating all 4 of these interfaces side by side reveals a really powerful trend. The learning curve, the human effort required, drops drastically as we move from the CLI all the way down to gesture. But here's the catch. As human effort drops, the hardware resource demand and system complexity just absolutely skyrocket. Put simply, the easier the computer is for you to use, the harder the operating system has to work in the background. And that brilliantly illustrates the entire macro history of the operating system. The history of this software is, quite simply, the history of shifting the burden of translation. Back in the day, with the command line, humans had to carry the heavy burden of learning the machine's language. But today, with dialogue and gesture, the machine carries the heavy burden of learning our language. We've effectively moved from a machine-centric world to a profoundly human-centric one. Ultimately, from managing raw hardware on a motherboard to tracking complex human gestures in 3D space, the operating system remains the unsung hero that makes modern computing possible. It really is the invisible engine of progress. As our technology gets more and more advanced globally, the OS just keeps getting better and better at hiding its immense complexity from us. Which leaves us with a final provocative thought to take away from our explainer today. As the machine increasingly masters our language and our movements, what will the operating system of the future actually look like? Seriously, what could possibly come after voice and gesture? Think about that the next time you seamlessly open an app on your phone. Thank you so much for joining me today. Stay curious, and I'll catch you in the next explainer.